Hello everyone, today we will be discussing about liquid vehicles, water and alcohol. Water, its formula is H2O, its molecular weight is 18. Cavendish, a scientist, proved that water is a compound. It is also called distilled water, aqua distillica, aqua purifica. For preparation in small scale, distillation and deionization are the processes that are employed. For large scale, electrically operated automatic water distillation is the process that is employed. Distillation process. Impure water is converted into vapor by boiling, and then the vapor is again converted back to the liquid by cooling. The apparatus required are Liebig's condenser, 2 flasks, Bunsen burner, tripod stand and wire gauze. Distillating flask with a side tube that is converted to Liebig's condenser, whose other end is inserted into a receiving flask to collect the distillate. Ordinary water in round bottomed flask is placed on a tripod stand for the wire gauze to boil. The mouth of the distillating flask is closed with a rubber cork and it is inserted with a thermometer. Once the boiling point is reached, vapors produced are cooled in the Liebig's condenser and it is collected in the receiver as purified water. And this is the process of distillation. On the left side, the round bottomed flask contains impure water and the Liebig's condenser in the middle, and the receiving flask is in the right, which contains purified water. Deionization process. Ion exchange resins which can exchange other cations and anions from a solution by hydrogen and hydroxyl ions respectively. The most commonly used cation exchangers are ZeoCarbH. Most commonly employed anion exchange resins are amberlite and IRA400. All the metallic ions are replaced by hydrogen ions with the formation of an equivalent amount of acids and corresponding anions of metal salts. The anions of resulting acids are replaced by hydroxyl ions in the cation exchange resin, forming water. This happens when impure water is passed through cation exchange resin and anion exchange resin. Hence formed water is called demineralized water or deionized water. The reactions that takes place in the cation exchange resin is, for example, calcium chloride. This reacts with cation exchange resin, that is 2HR, to give R2CA, that is a salt, and 2HCl, which is an acid. Another example, magnesium sulfate reacts with the cation exchange resin, results in the formation of R2Mg, which is a salt, and H2SO4, which is an acid. When this mixture is passed through an anion exchange resin, it results in the reaction, which is HCl plus RNOH, which is the anion exchange resin, results in the formation of RnCl, which is a salt, plus H2O, and H2SO4 plus 2RNOH gives rise to Rn twice SO4 plus 2H2O. First, the impure water passes through the cation exchange resin, resulting in the formation of salt and acids, and then it is passed through anion exchange resin, resulting in the formation of deionized water. For large scale, automatic water distillation is used, that is for commercial purposes in large scale manufacture. An automatic water distillator and stainless steel vessel known as still is used. In this process, the distillation and cooling is done by the same water. A portion of the cooling water will go through some holes into the heating chamber. The steam will be produced here, which will lead into the inner chamber through special passage at the top and comes down for cooling purpose. The cooling water will exit through an overflow as fresh and when it is needed. Properties of purified water are: it is neutral, its pH doesn't vary more than 6 to 7, its specific gravity is 1 at 25 degrees centigrade, its freezing point is 0 degrees centigrade, its boiling point is 100 degrees centigrade, and its maximum density is at the temperature of 4 degrees centigrade. The latent heat of fusion at melting point is 79.72 kilocalorie per gram. Latent heat of vaporization at boiling point is 539.4 calorie per gram. Heat of formation at 25 degrees centigrade is 68.32 kilocalorie per mole. Its critical temperature is 374.42 degrees centigrade. Its surface tension at 25 degrees centigrade is 71.97 dynes per centimeter. Its viscosity at 25 degrees centigrade is 8.937 millipoises. Its refractive index is 1.33300. It is a clear, colorless liquid. It doesn't have a taste and it doesn't have any odor. It doesn't conduct electricity due to negligible ionization. It readily forms crystalline hydrates with many compounds. It is a good ionizing solvent for acids, bases, salts. It is an amphiprotic solvent. Impurities in water and their detection. Insoluble substances are clay, sand and vegetable matters. Soluble substances are non-volatile substances like chlorides, carbonates, bicarbonates, sulfates of sodium, potassium, calcium, magnesium and iron. Detection of purity. Physical properties can be detected by using taste and smell. So if it is clear, colorless, odorless, tasteless, then physically it is pure. If its pH is not more than 6 to 7, it is also pure. Its boiling point is 100 degrees centigrade, then it most probably is pure water. And if its freezing point is 0 degrees centigrade, then it is pure. And if its temperature of maximum density is at 4 degrees centigrade, then it is considered to be pure. Then litmus test. If there is no change in blue or red litmus when in contact, then it is pure water. And if there is no residue on evaporation, then it is pure water. And if anhydrous copper sulfate is added and it turns into blue color, then it is pure water. If potassium reacts to form hydrogen, which spontaneously undergoes combustion, then it most probably is pure water. For identification of chloride, the reagents added are silver nitrate and dilute nitric acid. And if there is any white turbidity formed, then it is impure. For the identification of calcium, ammonium oxalate solution and dilute acetic acid are added, and if there is any white turbidity, then the given sample of water is impure. For identification of sulfate ions, barium chloride solution and dilute hydrochloric acid are added, and if there is any white turbidity, then sulfate ions are present in the given sample of water. For the identification of ammonia, Nessler's reagent, that is alkaline K2HgI4, is added to the given sample, and if there is any brown color or brown precipitate, then ammonia is present in the given sample of water. Uses of water are: it is used for cleansing of utensils or equipment. It is used for preparation of mother solutions of drug substances which are insoluble in alcohol. It is used for preparing reagents and in analytical purposes. It is used in external application for preparation of lotions. It is used for preparing of potencies. It is used in dispensing of medicines. It is used in rectal or vaginal pouches. Used for injection by allopathic physicians. It is used for preparation of different qualities of weaker alcohol, that is strong alcohol, dispensing alcohol, etc. It should be stored in Purex glass bottles which are previously cleansed in hot water. The demerits of water are: medicines dispensed with purified water cannot be preserved for long periods of time as aqueous solutions are unstable. Next is alcohol. Alcohols are hydroxyl derivatives of hydrocarbons. They are theoretically obtained by replacing one or more hydrogen atoms from the hydrocarbons by hydroxyl groups. Ethyl alcohol, it is also called ethanol, spirit of wine. Its chemical formula is C2H5OH. Its molecular weight is 46.07. The sources that are used for preparation of ethyl alcohol are molasses, which is a waste byproduct from sugar production, substances rich in starch, for example rice, wheat and maize, substances rich in sugar, example beet, carrot, grapes, from sugars, for example beet sugar, cane sugar, and synthetically from ethylene. Preparation of alcohol from starchy materials. From potatoes, for example, the potatoes are cut into pieces and then water is added, and this solution is agitated with superheated steam under pressure. This results in the formation of mash, which is a pasty mass, and then to this diastase is added, which is produced from barley that is allowed to germinate in darkness at 15 degrees centigrade. This results in germination of the barley seeds. When germination is stopped after a few days, malt extract is formed from it, and this malt extract contains diastase enzyme. This diastase enzyme is added to the mash. This results in the hydrolysis of starch, which results in formation of maltose. The conversion of starchy materials to maltose is called as saccharification, because maltose is a sugar. After that, the maltose is heated at 30 to 35 degrees centigrade and it is kept for 3 days. The maltase enzyme present in the yeast results in the breakdown of maltose into glucose. After that, the glucose is again broken down to form ethyl alcohol and CO2 due to the presence of enzyme xymase. The alcohol thus produced is only 15%. After that, the alcohol is subjected to fractional distillation, which results in the formation of 90 to 95% ethyl alcohol. The process from maltose to 90 to 95% ethyl alcohol is called as alcoholic fermentation. Properties of alcohol are: alcohol is colorless, it is neutral, it has a pleasant smell, it has a burning taste, it is transparent and it is volatile, it is hygroscopic and it is inflammable, that it is burns with a pale blue smokeless flame. In small doses it acts as a stimulant, and in large doses it is poisonous. It is a good solvent for organic compounds. Advantages of alcohol are: it is non-expensive, it doesn't have a medicinal properties of its own, it is neutral in reaction, it is not spoiled by long storage, it is soluble with almost all common fluids, it is edible in small doses and it acts as a stimulant. The preparation of it is easy and it has great extracting powers for the medicinal properties of drug substances. Disadvantages of alcohol are: it evaporates easily, it is highly inflammable, ordinary corks that are used are easily discolored by overfilling, it is highly taxable item, it is not procured easily, it cannot dissolve many inorganic salts directly, albuminous and starchy substances are not dissolved, in large doses it is poisonous. Precautions to be taken to store alcohol are: it must be stored in cool and dark place and in airtight containers. Alkaline bottles should be avoided at all costs. Bottles made of Pyrex glass should be preferred. It should be kept away from fire due to its inflammable nature. Uses of alcohol are: it is used for preparation of mother tinctures and mother solutions, it is used for preparation of dilutions and potencies, it is used for preparation of medicines and medicating the globules, it is used as an antiseptic, it has cooling effect, so it is applied on burns, it is used for storage of medicinal substances. Impurities of alcohol are: fusel oil, succinic acid, water, and other alcohols like amyl alcohol, propyl alcohol, butyl alcohol, glycerine, and acetaldehyde. Detection of impurities in alcohol. The given sample of alcohol is soaked with blue litmus paper. If it turns red, there is acid present in the given sample. Purified water is added to the given sample of alcohol in equal volumes, and if there is any foreign smell, it is impure alcohol. For fusel oil identification, a few drops of silver nitrate is added to the given sample of alcohol in a clean test tube and it is exposed to bright light, and if any reddish color is found, then fusel oil is present. Equal amounts of concentrated H2SO4 and alcohol are mixed. If there is any red or brown color, then fusel oil is present. A small quantity of alcohol is made to evaporate from a porcelain dish, and this process is protected from dust, and if there is any foreign odor it is observed, then fusel oil is present in the given sample of alcohol. Identification of water. 10 cc of alcohol is shaken vigorously with 0.5 grams of anhydrous copper sulfate. If the powder turns blue color, then water is present in the given sample of alcohol. If calcium carbide is added to the sample of alcohol and acetylene gas is produced, then water is present in the given sample of alcohol. Identification of methyl alcohol. Oil of intergreen test is used, that is 3 to 4 ml of alcohol is taken in a test tube and 1 gram of sodium salicylate or salicylic acid is added to it, and then 1 ml of concentrated H2SO4 is added and then it is warmed. If a characteristic fragrant smell of methyl salicylate is observed, then methyl alcohol is present in the given sample of alcohol. Types of alcohol. There are 5 types of alcohol. They are absolute alcohol, strong alcohol, dilute alcohol, dispensing alcohol, and rectified spirit. Absolute alcohol. It is also called anhydrous alcohol or alcohol dehydrated. It is entirely free from water, that is, it is 100% pure. Its specific gravity is 0.792 at 15.6 degrees centigrade. Preparation of absolute alcohol from rectified spirit and quicklime. Rectified spirit and quicklime are added and then they are heated, due to which most of the water present is removed. After that, this is subjected to distillation. After distillation, there is only about 0.6 to 1% of water, and then the solution is refluxed over metallic calcium and magnesium, and then it is redistillated in all glass apparatus. The first and last portions of the distillate is rejected, and the middle portion contains pure and unmixed absolute alcohol. On large scale, rectified spirit is mixed with little benzene to form absolute alcohol. After that, it is subjected to distillation. The first fraction contains only 18.5% of ethyl alcohol and 7.4% of water and 74.1% of benzene. After second distillation, the second fraction contains 32.4% of alcohol and 67.6% of benzene. And then after another distillation, the last fraction contains pure and anhydrous alcohol. Strong alcohol. It is also called alcohol fortier or alcohol fortis. It is obtained after secondary distillation, so its volume is 95%. The specific gravity is 0.816 at 15.6 degrees centigrade or 60 degrees Fahrenheit. Its refractive index is 1.3637 to 1.3639. Preparation of strong alcohol is by mixing of 94.9% ethyl alcohol and 5.1% by volume of purified water. It is used for preparation of mother tinctures as in new and old methods, and also for preparation of absolute alcohol, dilute alcohol and dispensing alcohol. Dilute alcohol. It contains 62.5% volume by volume or 60.6% weight by weight of absolute alcohol. 695 ml of strong alcohol in 1000 ml of water gives dilute alcohol. Its specific gravity is 0.9139 to 0.9169 at 20 degrees centigrade. Preparation of dilute alcohol. According to American Homoeopathic Pharmacopoeia, it consists of 7 parts of alcohol and 3 parts of purified water. As per British Homoeopathic Pharmacopoeia, it contains equal quantities of rectified spirit and purified water. Dispensing alcohol. It is also called alcohol officinalis or official alcohol. It contains 88% by volume or 83.1% by weight of ethyl alcohol. Its specific gravity is 0.840 at 15.6 degrees centigrade or 60 degrees Fahrenheit. It is prepared by mixing 10 parts by weight of strong alcohol and 1 part by weight of purified water. It is also prepared by mixing 12.25 parts by volume of strong alcohol and 1 part by volume of purified water. Rectified spirit. Rectified spirit 60 degrees overproof means that 100 volumes of alcohol diluted with 60 volumes of purified water, which gives 160 volumes of proof spirit. It contains 91.29% by volume of ethyl alcohol. Its specific gravity is 0.8294 at 15 degrees centigrade. Rectified spirit 40 degrees overproof is prepared by mixing 7 parts of strong alcohol with 1 part of purified water, both by volume. Rectified spirit 20 degrees overproof is prepared by mixing 6 parts of strong alcohol with 2 parts of purified water, both by volume. Denatured spirit. Denatured spirit is also called methylated spirit. It is rectified spirit that is denatured by mixing methyl alcohol. Proof spirit, it is used in alcoholometry. It is the mixture of alcohol and purified water, which weighs 12 by 13th of equal volume of purified water at 51 degrees centigrade. Overproof. The alcohol which is stronger than the proof spirit is called as overproof. 10 degrees overproof contains 100 volumes of alcohol and 10 volumes of purified water. 30 degrees overproof contains 100 volumes of alcohol and 30 volumes of purified water. 60 degrees overproof contains 100 volumes of ethyl alcohol and 60 volumes of purified water. Underproof. The alcohol which is weaker than proof spirit. 10 degrees underproof contains 100 volumes of rectified spirit, which is 90 volumes of ethyl alcohol and 10 volumes of purified water. 30 degrees underproof contains 30 volumes of water and 70 volumes of ethyl alcohol. 60 degrees underproof contains 60 volumes of purified water and 40 volumes of ethyl alcohol. Thank you for watching.